As far as picking up these messages is concerned, a typical thing to do is write an Azure function or a logic app that picks these up. Those Azure services are covered in the second part of this course, the deep dive version. To be able to demo this, I'm going to use another endpoint in our Travel Inspiration API. Process Destination Images Changes endpoint. The boilerplate code for this is already in the starter solution, but as you can see at line 36, the implementation isn't here yet. That's what we're going to do now. Just as before, let's start with injecting a queue service client. There we go. And let's get a client for our image message queue. That's exactly the same as we did in the previous demo. There we go. What you want to do with the received message depends on your use case, obviously. For the demo, I'm just going to return the messages we receive in the response body. So let me new up a message DTO list to hold the messages as DTOs. The message DTO class, that's a class I previously defined here. Then I call into receive messages async on the queue client. I can pass through the maximum amount of messages I want to see returned in one go here. Say 10, and the cancellation token, of course. This gives me a list of queue messages I can iterate over. Of each queue message, we can then read properties like when it was inserted, when it expires, the body, and so on. The actual messages can be accessed via the value property on our messages response. What we want is the actual content of the message. That's the JSON we sent in the previous clip. And that is contained within the message text property. So we deserialize that to a message DTO. If this succeeds, we want to add that to the list of message DTOs that's returned in the response. After that, we delete the message from the queue. For that, we call into delete message async. Important to know is that messages are not automatically deleted just by fetching them. Like that, you can make sure that you only delete them after you were able to correctly handle them. To delete a message, we need to pass through two things. We need to pass through the message ID and something called a POP receipt. That POP receipt is a property associated with a message in a queue. It is used to manage the visibility of the message and to ensure that it is only processed once. When a message is received from a queue, it becomes invisible to other consumers for a specific duration. That duration that is called the visibility timeout. So during this time, the consumer has exclusive access to the message and can process it. The POP receipt is a unique identifier that is generated when the message is received and that is used to thus track the visibility of the message. So once the consumer, in this case us, correctly processes the message, it can delete the message from the queue. And to delete that, we need to provide the POP receipt along with the message ID. And that is what ensures that only the consumer who received the message can also delete it, which prevents other consumers from processing it again. So I pass through the message ID, the POP receipt, and of course a cancellation token. After all of that, we return the list of processed messages. Let's give that a try. So to test this, we simply need to send a request to process destination image changes because the messages are still there from the previous demo. Let's send that request. And there we go. Here's our two messages. Now let's have a look over on the portal. Let me refresh this. And indeed, the messages are no longer on our queue. In this section, we will deploy our API to the app service. What you now typically would do is choose publish. But that won't work anymore. Because if you've been following along with the course, you remember that we first created an app service via the portal, then published to that app service, then deleted that and recreated the app service via the CLI. That means that our previous published profile is still linked to the app service we manually created, and that one doesn't exist anymore. So an easy way around that is to simply remove that and choose publish again. We can now add a new publish profile. We're still publishing to Azure. This isn't new, We're publishing to the Azure App Service again. We make sure we have selected the correct subscription and then select the correct app service. And let's click Finish. And here's our new profile. Interesting here is that we now have a new service dependency. A service dependency on storage, as we're using a storage account. Also, the dependency on the SQL Server database is still ignored, which is how we previously configured it, and that is still what we want, because we're not integrating with Azure SQL yet. Interesting to notice is that for our storage account, a connection string has to be provided. Remember that we previously edited app settings? Well, I mentioned then that connection strings can be managed in the same way. It's just that we didn't have a need for it then. Well, funnily enough, we still don't. Connection strings to storage accounts are not intended for the connection strings section over on Azure. That's for connection strings to databases like SQL Azure. But they are intended for the regular app settings section. So it does make sense to add it here. This, by the way, does more than simply store a few settings. Behind the scenes, this also ensures that the correct dependencies are checked and installed, and that an Azure Service Connector resource is added. So to effectively connect to this dependency over on Azure, we click these three buttons here and choose to connect. We select the correct account, and we choose the connection string. That's the connection string that's already defined in our app settings. Now let's click Finish. So what this is the Azure Service Connector at work. This is a resource that configures network settings, connection information between compute services like app services, and target backing services like a storage account or a SQL Azure resource. In other words, this does a bit more than simply store some settings. It ensures that the storage account and the app service can correctly interact with each other over on Azure. Alright, let's click Close, and let's choose to deploy this. So I click Publish here. That seems to have worked. Let's give this a try, for example by getting the destinations. That calls into our table storage and blob storage, as you remember. So if this works, the connection to our storage account is successfully set up. And there we go. That works. One final check. Let me open our app service and have a look at the environment variables. And there we go. As expected, we have new app settings here containing connection strings to the storage account. Out of the box, it does create a few additional settings. One to the root endpoint of each common type of storage. We currently don't use that in our application. We have this one connection string we use for all of them. So if you don't need these, you can safely remove them. But anyway, this is how to publish an application that connects to Azure Storage. Time for the section summary. This section was all about working with Azure Storage. Azure Storage is a cloud storage solution offering the things you can expect from it. High availability, replication, scalability and security. It's also a managed platform as a service. The most important types of storage are, in my opinion, table storage for storing non-relational structured data, so no SQL. Blob storage for storing large amounts of unstructured data like images, documents and videos. And queue storage for storing messages that can be processed asynchronously. Other services include file storage, Elastic SAN, managed disks and container storage. These are all tied to storage accounts. Storage accounts provide a unique namespace for Azure Storage data, accessible over HTTP or HTTPS. So it starts with that account, and underneath you have your table storage tables, blob storage containers and so on. All that data needs to be managed, of course. You can do that via the portal, but Azure Storage Explorer, which is a tool for managing data, is an easier option. It enables easy import and export and management of storage data. To integrate an application with Azure Storage, storage can be accessed using access keys, connection strings or shared access signatures, with the latter offering more granular control. You can integrate directly via a REST API, but client libraries that wrap around that exist for .NET and other languages. Those are easier to use when you need to integrate with Azure Storage Services. Lastly, when you deploy an API that connects to Azure Storage on an app service, dependencies need to be configured, like network settings and a connection between the app service and Azure Storage, and so on. A convenient way to manage this is through an Azure Service Connector resource, as we did. So, we learned a lot about storing data, but one obvious candidate was missing: Azure SQL. Let's learn about that next.